Good, the final part of the word embedding tutorial in PyTorch, so part 3 of the PyTorch NLP tutorial, is a little exercise where you should just build a neural network similar just to the example given above. Before we wanted to predict, like have a language model, we have two input words and we want to predict the next word. In this example it's similar, but we want to do create a SIBO model, continuous bag of words model, like in which is one algorithm in word2vec, where you predict from the context to a word, and here the context is the words before and also the words after the target word. So in this example we will have a context of 2, so we take the 2 words before and the 2 words after a given word and use those to predict the word. This is also a common algorithm to train word embeddings. So please read the description here of this exercise and try to implement this model. So you can do it on your computer, you don't need a GPU to train on such small data. Just make a model and train it similar to the one above. And as a starting point they give you some code, some text you should use, define a context size, how to create the vocabulary size, a function to get from words to indices to numbers, and then a function to create the input data, which is you create the context, so the 2 words before the words and the 2 words after the word, which is the context for a single word, and the target is the word in between. And we add this to this data variable which contains our training data. Okay, and then they give a skeleton of the SIBO model which you should implement. And finally they give another function to create the input context into a torch tensor of IDs. And we print some of those created things, where we basically just print a couple of examples of the training data. So we have 4 words. We are, then about would be the word in the middle, to study. So we have those 4. We have to predict about. Okay, so please implement this as an example inside the lecture, and do also some predictions. So once you have a model trained, use it to make some predictions to see if it does anything useful. I mean, with this kind of training data which you have here, you cannot expect the model to do much of useful things, so you would need to train it at least on a book or something to have a good SIBO model or language model. But it's just to see how can you do predictions, also make a couple of predictions. Okay, you can stop here, do the implementation. So for the exercise on word embeddings, one sample solution I provide on GitHub in Unit 7, my Python notebook. So it's, you can just have a look at the solution. So here is basically the code which was given in the exercise, including this function and the skeleton for the class. And then here I implement the SIBO model. It's very similar to the implementation which is used on this Ngram language model. So we have embeddings as input, the embedding layer, which has the vocabulary size and the number of embedding dimensions. Then we have a linear layer, which gets the context size as input. So the size of the linear layer is the embedding dimensions multiplied by 2, because we have the context on the left and the right, and then we have 2 words. So this is like 4, 2 multiplied by 2. And we have as output of this layer 128 notes again, and then we have a final layer to project it to the vocabulary size to make our final class predictions. The forward layer is also very similar to the example in the notebook on the PyTorch website, so we don't have to look into that too much here. And then we define the training loop. I used 20 epochs. It's pretty much, so you can have a look at it. I don't need to go through all the code here. Pretty much the same like in the example. And then finally we do some predictions. So for this I just take a test sentence, which I have here, split it into words. Then from those words I create the context data, so for the parts of the sentence, creating the context data for words, 2 before and 2 after a target word. So we just create basically another small training set, but it's not a training set, it's a testing set basically. Then we have those functions to get from indices to words and from words to indices, functions or dictionaries. And then here we do the predictions. So we put this into this torch Node-RED block. I hope you already know what the purpose of this is. So it's just to not compute gradients, because we don't do any training here, we just test, so we don't need to compute the gradients for this data. Then we iterate over the input data, make those context IDs, which these tensors which are fed to the model, and get the probabilities. And then here this is maybe the most interesting part. We have some probabilities for all our words in the dictionary. So we have predictions for the words and probabilities connected to those predictions. And we just want to pick here the word that has the highest probability. And we pick this word with the argmax function out of this tensor, and put it into a Python ID, which is then stored into this predicted index variable. And then we can have a look into our dictionary which word is predicted. So we have some examples, so we have some context. It's actually here, so here we have the predictions. So we have the input context and the predictions. So the prediction for we study idea of was the, which makes sense, we studied the idea of. And the second example, study the of computational, so the prediction is study the idea of computational, blah blah blah. Okay. I think these things were more or less in the same way in the training data, so the predictions are quite good. If we have a sentence structure which has not been seen in the training, because the training data is so small, then we'll probably not get a good prediction with this very simple small model. Okay, so this concludes the parts on word embeddings.